Hey everyone, and welcome. Today we're going to talk about one of humanity's oldest and honestly most amazing building materials. This is a substance so important it literally held empires together. So get ready to dive into the magic of lime.
So let me just kick things off with a question for you. Think about two of the most mind-blowing engineering projects in all of history, the Roman aqueducts and the Great Wall of China. What could they possibly have in common? I mean, they were built thousands of miles and hundreds of years apart.
The answer is this incredible material, lime. It was the original superbinder, the mortar that literally held together ancient civilizations and created buildings that are somehow still standing today.
Okay, so what is this stuff really? The name itself sounds super simple, but the chemistry that turns a plain old rock into a powerful construction material is actually pretty incredible.
It all begins with a super common rock, limestone. At its heart, lime is what you get when you take that limestone, heat it up like crazy, and totally transform its chemical structure. We're essentially baking a rock to unlock its hidden superpowers.
So, how do we actually get from a simple stone to this amazing building material? Well, it's this fascinating, almost magical three-step process.
First, you got to get the limestone out of the ground. Then comes the really dramatic part. You burn it in a kiln, which is basically a giant super hot oven. And finally, you have to slake it, which means adding water to set off one last really powerful chemical reaction. Now, the real heart of this whole transformation is a process called calcination. You're heating that limestone to about 900 degrees Celsius. By doing that, you're literally forcing it to release carbon dioxide, and that completely changes what it is on a chemical level.
And this slide just perfectly illustrates that change. You start with this stable, predictable thing, limestone, or calcium carbonate. After you bake it, the stone has basically exhaled all its carbon dioxide. And what's left behind is this highly reactive, kind of unstable powder we call quicklime or calcium oxide.
The final step is like quenching the lime's thirst, and it's pretty wild. When you add water to that reactive quicklime, it kicks off this huge exothermic reaction, which just means it gives off a ton of heat. It literally hisses and steams, and in the end, it transforms into the usable stuff we know as slaked lime. Okay, so we have our lime. But, and this is a big but, not all lime is created equal. It really depends on how pure the original limestone was. So let's kind of explore the whole family of limes.
Generally speaking, building limes fall into three main categories, and it all just comes down to the purity of that original rock. You've got fat lime, which is super pure, hydraulic lime, which has some clay mixed in, and poor lime, which, well, the name kind of gives it away. It has a lot of impurities.
So this is the really crucial part, especially the difference between the two main types. Fat lime is almost pure stuff. It sets really slowly by just grabbing CO2 back from the air. But check out hydraulic lime. It has clay in it, and that one simple impurity changes everything. It lets it set through a chemical reaction, which means it can even harden underwater, and it gives it way more strength in the end.
And then you've got poor lime. With more than 30% clay, its ability to bind things together is pretty weak. This is the low-grade material, used for basic, non-structural stuff where you really don't need a lot of strength.
So now that we have these different types in mind, where do we actually see them being used? Let's take a look at lime out in the real world.
You see it all over the place in traditional building. That beautiful, perfectly white fat lime, that's ideal for a really smooth plaster finish. The stronger hydraulic lime is what you want for a mortar to hold bricks and stones together. It's also used for pointing joints, for a simple whitewash on walls, and even to help make soil more stable.
So after literally thousands of years, why are we still talking about this stuff in an age of modern cement? Well, it turns out lime has some pretty unique qualities that we're starting to appreciate all over again.
Unlike modern cement, lime is breathable. It lets moisture escape from inside walls, which is huge for preventing dampness. It's also more flexible, so it can handle tiny shifts in a building without getting big cracks. And get this, for sustainability, as lime hardens, it slowly reabsorbs all that carbon dioxide that was burned off in the kiln. It basically locks it back into the wall. It's this beautiful, simple, circular process. Which really brings us to our final thought. With its breathability, its flexibility, and its incredible ability to reabsorb CO2, could this ancient supermaterial actually hold a key to the future of more sustainable, green building? It's definitely something worth thinking about.